Good day, students. I am Dr. MONIKA KHETARPAL. I am Associate Professor of Physics in Government Dungar College, Bikaner. Today I am going to deliver a lecture on classical mechanics. This is first paper of MSc Previous Physics. In my earlier lecture, I have taught you what are constraints. Constraints means restriction. That means a free particle motion has been restricted. I have classified constraints into two types, holonomic and non-holonomic constraints. Holonomic constraints are those constraints which are expressed by equation function of coordinates x, y, z, t equal to 0. Constraints which cannot be expressed in this form are called non-holonomic constraints. That means we have classified constraints on the basis of a equation. There is another method of classification of constraints. This is not based on equation, but it is based on the dependence of time. If constraints depend on time, they are called scleronomic constraint. And if constraints are independent of time, they are called rheonomic constraints. Hence, classification is of two types, on the basis of equation and on the basis of time dependence. Now, I am giving the example of both these constraints. Since scleronomic constraints are the constraints which do not depend on time, as in a rigid body, there is no time dependence. The distance between the particles will always remain same. There is no time dependence. Hence, rigid body is an example of scleronomic constraint. Another example of this constraint can be pendulum. In pendulum, restriction is that length of the bob from point of suspension will always remain constant. This factor also do not depend upon time. Now, I am going to state the example of rheonomic constraint. For rheonomic constraint, I am taking this wire. This wire is moving, rotating in a prescribed fashion. I am taking a bead on this wire. That means I am sliding this bead on the moving wire. Since this wire is rotating, that means it will have a definite time period. So the motion of the bead which is on this wire will also have a definite time period. That means there is a constraint that bead will move on the wire, but this constraint is time dependent. It depends upon the time period of the wire. Hence, this is an example of rheonomic constraint. Now, introduction of these constraints has imposed two problems in our system. What are these two difficulties? Since we have imposed the restriction on a rigid body, that is the distance between the constituent particles I and j, which is denoted as Rij, this will always remain constant. And in pendulum, the distance of the bob from point of suspension will always be equal to the length of the thread. That means R will always be equal to L. There are restrictions on bodies. These restrictions are denoted by equation of constraint. That means our coordinates are no longer independent. For example, in the rigid body case, if I know the coordinate of particle I, that means Ri is known to me, then the coordinate of particle j will be determined by the condition Ri minus Rj equal to Cij. That means equation of constraint bounds the coordinates now. So coordinates are no longer independent. The second difficulty by using the constraint is that the force that is required to maintain constraint in the system is not known to us. For example, when we are taking a bead which is moving on a wire, then we have restricted our bead to move on the wire. But we do not know the force that the wire exerts on bead. Hence the force of constraint. These are termed as force of constraint. These force of constraint are not known to us. Hence we have to solve our problem. Then we have to first of all resolve the two problems. So we are going to resolve these two problems. The first difficulty, that is our coordinates are no longer independent. This difficulty is solved by using generalized coordinate. What are generalized coordinate? I will deal later. The second problem, which is the force of constraints, they are not explained. This problem is removed by using the mechanics in such a way that force of constraint do not appear in our problem. That means force of constraint, they are taken to be 0. Degree of freedom. What is degree of freedom? As we already know, the number of independent coordinates that are needed to specify the position of a particle is termed as degree of freedom. For example, we are taking a free particle. This free particle in space in Cartesian coordinates will have 3 degrees of freedom, that is x, y, z. Now, if we are having a n particle, then degree of freedom will be equal to 3n. Now, in the first problem removal, I have stated the term generalized coordinate. Now, I am going to discuss what are generalized coordinate. Here for a n particle, I have already stated that we need 3n independent coordinates, which were degree of freedom. Now, if the system is free, there are 3n coordinates. Now, what I am doing is that I am imposing k independent constraints on the system. Now, in this condition, the degree of freedom will change. The degree of freedom, which initially was 3n, I have imposed k constraints. Now, degree of freedom will be equal to 3n minus k. These 3n minus k coordinates are independent now because we have removed the constraints. These set of 3n minus k independent coordinates are called generalized coordinates. That means generalized coordinates are independent coordinates. They are denoted by letter small q. We are considering a system in which there are n generalized coordinates, then they will be represented as q1, q2 till qn. The advantage of these generalized coordinates is that they specify the configuration of system and they simplify our mathematical calculation. And they also do not violate the condition of constraints. Now I am taking the example of these generalized coordinates. For example, I am considering a particle which is moving in a xy plane. Since two coordinates are needed in Cartesian coordinate to describe its position, there will be two generalized coordinates. As I have already stated, generalized coordinates are denoted by letter Q. So Q1 will be equal to X and Q2 will be equal to Y. If instead of generalized coordinate, I am using polar coordinates, then polar coordinates are r and theta. Then first generalized coordinate Q1 will be equal to r. If it is changed in Cartesian coordinate, it is expressed as r equal to under root x square plus y square. And second set of generalized coordinate will be equal to Q2, which will be equal to theta. Theta is related to Cartesian coordinate as tan inverse y upon x. So there are constraints which means restriction, and these constraints were classified on the basis of equation as holonomic and non-holonomic, and on the basis of time dependence, rheonomic and scleronomic. And there were two difficulties that were involved by using constraints. These two difficulties were that there were force of constraints which were not specified, and another difficulty was that coordinates are no longer independent. They are connected by equation of constraint. And we have resolved these two difficulties. First difficulty, that was removed by using an approach in which force of constraint were taken to be 0, and the second difficulty was resolved by using generalized coordinate, which are independent coordinates and they are denoted by a letter Q. In our next lecture, we will derive D'Alembert principle, and using D'Alembert principle, we will derive Lagrangian equation. Thank you, students.